So oblique impacts, and with what we've currently got is two different balls. The first thing is I can see that in the question, the lines of center is parallel to J. So we're probably going to have two different balls that are one on top of each other right before they collide. The lines of center, which is a vertical line, is parallel to the vector J, which means that horizontally everything is going to stay the same. Now, the other thing is they gave us two different vectors immediately after the collision. The question says velocity of A is a direction that's going kind of downwards, 3 towards the right, 1 downwards. And we've also got direction of B is something that's going up. So 3 and minus 1 is a vector that goes down, and 2 and 1 is a vector that goes up. So in terms of the relative position, the only thing that's possible would be 3 and minus 1 being a vector that's below, and 2 and 1 being a vector that's above. Because how else can they collide, and after they collide they have to go separate ways? They can't be going the same. So it couldn't be like, for example, that won't be something that's possible because they've already collided. So that would kind of be like the relative position afterwards. I usually label them as, because we've got 2 and 1 as B, and we've got 3 and minus 1 as A, I usually label them as final of B and final of A. Now, we've also got horizontally, in terms of a velocity, it's going to maintain the same. Which means that in this particular question, we do not have a before. So I'm going to call U of A, and sorry, U of B first, and U of A. Now, walking around, two things that I see. First of all, you know 2 and 3 will maintain the same. But another common assumption that I've seen you do is some of you do some arrows to say that they approach. If your arrow is actually a downward arrow and an upward arrow, you have already assumed that right before they collide, they are approaching each other. And what that means is your x and y as a vector would be minus x and positive y. But if you assume that as positive x and positive y, then your direction will be they approach like this. It doesn't actually matter. But if you want to treat it as a vector, you need to know that x and y is a scalar number for which the column vector 2x would be a full vector. Is that okay so far? Now what that means is depend on your assumption. Which one do you want me to assume? Do you want me to do x and y within my vector? Or do you want me to do minus x and y within my vector? I don't really mind. X and y. So if I do x and y, my arrow would start off like this, and depend on the answer that I get, my arrow will change. So I'm going to call that as positive x, positive y, because that's what you want me to do. Which means that your conservation of linear momentum together with your coefficient of restitution will only happen along the blue highlighted direction, the impulse direction. What that means is we've got a simultaneous equation. Your conservation of linear momentum with the mass as 2m for A, and the mass as m for B, would give us 2m bracket. Now this one is up and up, this one is up and down, which must mean that when you do 2m, it will be positive x. 2m, it will be positive y, and m will be positive x, because they're both going upwards where up is positive. We've also got your final, so you've got 2m lots of minus 1 and also m lots of 1. With that, we have got our first equation, x plus 2y equals to minus 2 plus 1. So that's minus 1. First equation. Your second equation, which is your Newton's law of restitution, notice that they're both going up. If they're both going up, in order for collision to occur, which one will be faster? The bottom one will be faster. So in terms of the relative speed, it will then be y minus x instead of x minus y. So therefore, you have E equals to separation. Separation would be 2 because they're going separate way. One is going up, the other is going down. So the relative speed is 2. If they're going to the same direction, you're subtracting them. If they're going separate ways, you're adding them, which in our case is going for the separation divided by the approach. The approach one is going together. Therefore, because the faster one is y, the slower one is x, we'll do y minus x.
Instead of they going in separate directions.
Instead of they going separate directions?
Then we're going to add them.
Yes. If they're going separate direction, we're going to add them. So for example, when it's approaching, if we assume that they're approaching like this, then the relative speed of approach will be x plus y, but our minus here will still be a vector minus.
How about the minus 1 and the 1?
How about the minus 1 and the 1? Because we are going separate ways. This is a scalar 1 and a different scalar 1. So therefore, we're adding the two scalars to have 2 in total. So in our case, we've got a simultaneous equation now. And yes, another question.
Why did you do y minus x, not x minus y?
Why did I go? So look, we need a collision to occur, right? One particle is going up by x, another particle is going up by y. In order for a collision to happen, y has to be faster than x. So for example, if x equals to 3, y has to be a number that's bigger than 3. Let's say 5. The relative speed is then going to be 5 minus 3 instead of 3 minus 5.
Sir,
Yeah.
how can we assume that they're both going up?
I could have assumed them as negative. If I assume this as negative, then here I need to put minus here. But when I do this one, it will be plus. Because it would be the total relative speed. But anyway, what that means is, yes, another question. For the separation, why? Because it's a speed. It's a speed concept. So speed can't be negative, isn't it? So I add them together because we've got one up and one down. So together would be 2. Now you've got a simultaneous equation, which is x plus 2y equals minus 1. And minus x plus y times by e. What was e? E is a half. Since e is a half, that gives you 2 divided by a half, which is 4. So you've got 2 equations. Because e goes to a half. What then allows us to do is when we solve our simultaneous, we've got simultaneous equation 2 unknowns, 1, 2, minus 1, minus 1, 1, and 4. So x is minus 3, and y is 1. Do you see we've got x as a negative number? X is a negative number. What does that mean? That means that our scalar number here, which is a positive, was actually not positive. It was actually coming downwards like this. So your UB was 2 and minus 3. We've got a negative answer anyway. And we would have got a positive answer if we assumed that as minus x. And another thing is our free y is 3 and 1. So we've got our full vector now as our velocity of 2 spheres. Immediately afterwards, we've got our impulse. Impulse on A or impulse on B. Impulse on A and impulse on B have to follow your conclusion from earlier. Notice that it doesn't matter which one you do. If you do I equals to mv minus mu on the A particle, then what you have got is 2m lots of 3 minus 1, taking away 3, 1. So that gives you 0 and minus 4m. If you do for m on impulse on B, you've got I bracket 2, 1, taking away 2 and minus 3. In our case, we've got m bracket 1 minus 3, which is 1 plus 3. So we've got 4m in the j direction, and we can clearly see they're equal and opposite. The question is only asking for the magnitude, so it would just be 4m. So in our case, it would be kind of like as a double checking step as well, because we can see the impulse is equal and opposite. And another thing is, it's a typical exam question where they like asking us tan theta. In most cases, they can give us the tan theta as well, or they can give us the angle of deflection, and we go back and use the compound angle formula of tangent. So what you could have done, because we're only focusing on the A only, and we're looking at the deflection.
Wait, does it say A only?
Yeah, the question is talking about the motion of A is deflected by. So the angle between the velocity of A after and the velocity of A before. There's two common methods that you can use. The first common method is vector A equals to 3 and 1, vector B equals to 3 and minus 1, and then you can do A dot B equals to mod A mod B cos theta. But the problem is, if I use this formula, I can find cos theta, and I will need a way to convert cos theta to tan theta. So that would usually be the longer method. Notice that we've got mod A to be, what was that? Root of 10. Mod B to be root of 10 as well. So A dot B, which is 9 minus 1. That's 8. So we can sub it in and say A equals to root 10 cos theta. And you've got cos theta to be 8 over 10. So of course, if you want to, 8 and 10 would give, it's a 3, 4, 5 triangle. So that must be 6, isn't it? So you can then go in and say tan theta is 6 over 8, which is 3 over 4. But that would not be usually the method that I stick with, because I prefer to use the gradient equals to 1/3 and the gradient equals to minus 1/3. Because if I have the gradient between them, I have the tan alpha and I have the tan beta. The angle between two angles would then be tan of alpha minus beta. That's tan theta. And that's quicker because I could just say 1 over 3 minus 1 over 3 divided by 1 plus 1 over 3 minus 1 over 3. That is the compound angle formula.
How do you know how to do alpha minus beta?
How do I know whether not to do alpha minus beta or beta minus alpha? Depends on which one is greater. Tan alpha is bigger. Tan beta is smaller. So I will do big minus small divided by 1 plus the multiple of them.
Can you draw them?
Can I draw them? Yeah. So do you see one is going down, the other is also going down. Well, one is going down, and then no, A is going up. So the angle of deflection will be this one. But it's easier to draw them as, for example, a line going up, and that would be beta. A different line going up, this whole angle will be alpha. The angle between them is theta. And then the gradient will be tan alpha. that would be tan beta being the other gradient. So the angle between them will be tan of alpha minus beta. In our case, once we've got that, we can then say we've got 2 over 3 divided by 8 over 9, which is 6 over 9 over 8 over 9. And we can clearly see that's 3 over 4 as well. I hope that's okay. Any more questions? Yeah? So that's collisions between poles with poles.